Hey, 7th grade. So this next video is going to start our next unit of study, which is going to be over lines. If you remember in the last unit, we got an introduction to functions, and we learned how to tell whether a relation was a function or not. And then we learned how to make graphs of functions using a table of values. Okay, we talked about the different function families, and one of those families was the linear functions. And so this next unit, we're going to kind of put to side all the rest of those function families that we talked about and just focus on the linear function family. And we're going to learn a lot more about that specific family and how to work with graphs of lines. Okay, so the first thing I want to talk about in this first video is this concept of slope. And so I'm going to use the example here on this first page of riding a bike uphill. And so if you follow along with me in this box here, it says you and your friend are taking a week-long trip on your bicycles. On the first day, you come to a hill that has a sign that says 8% grade. You tell your friend that this means that the hill has a vertical change of 8 feet for every 100 feet change in horizontal distance. And so we're going to learn a couple of vocabulary words in this box here. The vertical change, okay, so that's that change of 8 feet that your friend or you are referring to in this example, is what we're going to refer as the rise of this hill. And then the horizontal change, we're going to call that the run of this hill. Okay, so if you imagine your hill down below here, I kind of have a little makeshift hill drawn for you. Okay, this base part right here, okay, this would be the horizontal part of the hill. This is what we call the run. Okay, that's from this starting point right here to the top of the hill where you eventually reach the peak. Okay, the horizontal distance here is what we call the run of the hill, and then the vertical distance, okay, from this elevation to this elevation is what we call the rise of the hill. So that's what we mean by rise and run. Okay. We're going to fill in the boxes now to show what the rise and what the run are of this hill. So again, this hill was 8% grade, and we said that means that the vertical change or the rise of the hill is 8 feet. Okay, so from the bottom to the top of the hill, you're going up 8 feet in elevation. Okay, and you're traveling a horizontal distance from this point to this point of 100 feet. Okay, so the run of the hill is 100 feet, the rise of the hill is 8 feet. But when we're traveling up the hill, we're not actually going this 100 feet horizontal distance or this 8 feet vertical distance. We're traveling in a diagonal pattern. So this is the actual surface of the hill. So we're not only concerned with the horizontal change, we're not only concerned with the vertical change, we're concerned with the rate of change of this hill. And so we talked about rate of change in the last unit. Okay, the rate of change is defined as the change in the y value divided by the change in the x value. In this next unit, we're going to use a different vocabulary word to describe that same concept, and that word is going to be called slope. Okay, so I'm concerned with what is the slope of this hill right here. Okay, if we were to imagine this as being a line, what would the slope of this line be, or what would the change in the y values of this line be divided by the change in the x values? Okay, so we have a few different ways of defining slope. Okay, one way is saying the vertical change divided by the horizontal change. Another way is saying what is the rise divided by the run. Okay, well, the rise of the hill, we've already said, is 8 feet. Okay, you're going up a distance of 8 feet in terms of the elevation change, and the run of the hill, the horizontal distance, is 100 feet. So we would say that the slope of this hill is 8 out of 100, or an 8% grade, and whenever we're referring to slope, we always give that as a either fraction or a whole number. Okay, so 8 over 100, we're going to reduce that to 2 over 25. We would say the slope of that hill is 2 over 25, which means that for every 25 feet you go horizontally, you're going to go up 2 feet vertically. Okay, that's what this concept of slope means. It is the rise divided by the run, or the change in y divided by the change in x. And so what we're going to practice now in these next few examples is just finding the slope of different lines. Okay, rather than having actual hills, we're just going to be looking at graphs of lines here. And before you click play on this video, you should have filled in those blank graphs on examples 1 through 6 on your notes page, because I inadvertently left them off when I printed off your packets for you. So if you did not do that already, please make sure you do that. There is a second link on your Google Drive, okay, that has the 6 graphs and what the line should actually look like. So you can either print that sheet out, cut those out, and tape them over the blank grids, or just draw the lines in. Make sure they're the exact lines I have here. Make sure you use a straight edge, okay? Otherwise, you're going to be a little bit off when we go and we calculate the slopes of these lines. So if you've already done that, let's practice with how to find the slope of each of these lines. So again, slope, we want to remember, is defined as the rise over the run of a line. So each time we do a slope problem, I want you to go ahead and write that down just so it sticks in your memory. Okay, slope equals rise divided by run. So the first thing we're going to do is we're going to find the rise of this line. To find the rise of a line, you just need to pick 2 points on the line. Okay, so I've put in 5 points here for you. You just can pick 2 of those. So I'm going to go ahead and I'm going to choose this point here. That is the point -2, -3. And then this point right here. That is the point 2, 5. And rise means what is the change in vertical distance. So I'm just going to count the number of spaces between this bottom point and this top point. I'm going to go from the bottom to the top. And so that's going to be called a positive change because we're moving upwards. Okay? And so that's going up 1, 2, 3, 4, 5, 6, 7, 8 spaces. Okay, I'm going up 8 spaces to get from this bottom point here to the same level as this top point right here. So I would say that the rise of this line from this bottom point to this top point is a +8. Okay, and now I'm going to look at what the run of the line is. The run of the line would be the horizontal change. So now I'm going to go from where I'm currently at, which is this imaginary point right here, to my top point. Okay, and I'm going to look how many spaces do I need to go left or right. I need to move right, okay, and moving right would also be a positive change when we're referring to a coordinate plane. And I'm going right 1, 2, 3, 4 spaces to finish my little journey here. And so that means the run of this line is a +4. So the slope of the line, or its rate of change, is +8 over +4. We're going to reduce that to a +2. So we would say that the slope of this line here is +2. Okay, number 2, we're going to do the same thing. Slope, again, is defined as rise over run. And so I'm going to pick 2 points on this line, okay, to give me my rise and my run. I'll go ahead and I'll pick this point right here in blue, and then this point down here. Okay, so I'm going to start out with the rise of my line. And the rise of my line, I'm going to go ahead and start with the top point here, and that means I'm going to have to go down to get to my bottom point. Anytime I'm moving downwards, that is going to be a negative direction. So my rise, in this case, is going to be a negative direction. Let's count the number of spaces I need to move down. I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces here. So that means that the rise of this line is a -9. And then for my run, I need to move to the right. I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces again for the run. That is a positive change there, so my run is +9. So for my slope, I have a -9 divided by a +9, which is going to give me a -1. So we would say that the slope of this line is -1. I want you to also see that you could have picked 2 different points, and you could have gone from the bottom to the top. So someone else doing this example may have picked, let's say, this point right here and this point right here. They may have started with the bottom point, and so they would have gone up 1, 2, 3, gotten a rise of +3 over a run of, they would have moved left to get to the top point. Left we consider a negative direction when we're referring to a coordinate plane. 1, 2, 3 spaces. And so someone else doing this slope problem may have done +3 divided by -3, but they still would have come to a slope of -1. So I want you to see that no matter what points you pick on the line, as long as you're counting your spaces correctly and you're using the correct signs based on the direction you're going, you're always going to get the same slope as your neighbor. Okay, moving on to 3 and 4. I want you to go ahead and I want you to, on your own, click pause, try finding the slope of each of these lines, 3 and 4. Okay, and then once you think you've found the slope by counting your spaces, I want you to click play to check your answers, please. Okay, so for each of these lines, you should have gotten slopes of 1 for number 3 and positive 5/3 for number 4. For number 3, again, you can pick any 2 points I've given you on the line. For this particular line, I chose these 2 points right here. I started with my bottom point, and I had to go up 6 spaces to get to the level of my top point. So that's a rise of positive 6. And then my run was also positive 6, going to the right 6 spaces. So positive 6 divided by positive 6 is positive 1. For number 4, I chose these 2 points. Started with the top point. I had to go down to get to the level of my bottom point. Down is a negative direction, so I went down 5, and then I went to the left, which is also a negative direction, 3 spots. So that's negative 5 divided by negative 3. A negative divided by a negative cancels each other out, so that gives you a positive 5/3 for the slope for that one. Okay, moving on to 5 and 6. For these lines here, notice number 5 you have a horizontal line, and number 6 you have a vertical line. So for these 2 lines, I'm still going to pick 2 points here. I'm going to go ahead and just pick this point right here and this point right here. Okay, this horizontal line goes through all these points. And so to do my definition of slope, again, slope is defined as your rise divided by your run. Well, the rise of this line, we don't have to go up or down. If I start from this point right here, I don't need to go up or down to get to the same level as this point. I'm already on the same level. So I would say that the rise of this line is actually 0. Okay, so the run of the line, however, I can move left and right. If I start at this point, I need to go 1, 2, 3, 4, 5, 6 spaces to get over to this point. So I could say that the run is positive 6. Well, if you take 0 divided by positive 6, you still get 0. So really, it doesn't matter what my run is. If my rise is 0, that means that I have a slope of 0. And if you think about it, that's actually going to be true for any horizontal line. Every time you have a horizontal line, those lines are going to have, or those points on the line are going to have 0 vertical distance between them, so your rise will always be 0. Okay, so the moral of this story is that the slope of any horizontal line is always going to be 0. Okay, the same is not true for a vertical line. So let's look at number 6 and let's try finding the slope of this line. I'm going to go ahead and choose these 2 points right here. So for a vertical line, again, slope defined as rise divided by run. Okay, so for this line right here, my rise, okay, is actually going to be, if I start with the top point and go down, that's going to be going down 1, 2, 3, 4 spaces. So my rise, I would say, is negative 4. My run, however, I don't need to move left or right to get to this point. I'm already there, so my run would be 0. So we would say that the slope is negative 4 divided by 0. However, there is a rule in math that says whenever you're working with division, you cannot divide by 0. Okay, you can divide things into 0, like we did in number 5, but you can't have 0 in the denominator. So this is not allowed, okay, in math, and we would actually say that the slope in this case is undefined. Okay, so that's going to be true for all vertical lines. The slope of any vertical line is going to be undefined. These are 2 special cases anytime we're dealing with slope, and these are 2 that you really, really need to remember and commit to memory. Anytime you have a horizontal line or a flat line, the slope of it is going to be 0. Anytime you have a vertical line, its slope is going to be referred to as undefined. Okay, so I'm actually going to stop the video right here, and I'm going to post a second video to kind of break this section up, since there's a few more examples that are going to work a little bit differently that you still have in this section of notes. So if you'd like to take a break and then come back, the second video will be up on your Google Drive as well. It'll be called 5.1 Part 2, and that's where we'll take a look at the rest of the examples on your notes page. Okay, so once you're ready, you can start that second video, and I'll see you back there.